Good day, everybody. Welcome to Forecasting Consumer Demand. This is one of 3 or 4 short video lectures dealing with this topic. We're going to be looking at this PowerPoint. We'll be looking at an Excel spreadsheet in a few minutes, and we'll be looking at a Word document, all of which will be put in the resources page. First question is, why is forecasting demand, consumer demand, important in a consumer-type business? The same thing would be true in a business-to-business situation. But let's think of consumer demand. In terms of setting up your supply chain, your vendors, your suppliers, your distribution network, having some idea of what demand will be is important. Maybe your vendors won't have enough capacity. Maybe your own factory or operation won't have enough capacity. This is true whether it's a manufacturing business, a car dealership, the repair shop, a plumbing operation, or a insurance company, a service business. Forecasting demand is important for all those reasons. We're going to focus on a fourth reason, which has to do with pricing. So let's go back and look at a generic income statement. This would be for any business dealing with inventory. The tip-off to that is the cost of goods sold and gross margin lines. In a purely service business, you're not going to have any cost of goods sold or gross margin. You're just going to have a list of your selling, general, and administrative expenses. But let's assume you're making or selling some kind of a product. You might think of the cost of goods sold on a unit basis, cost of goods sold per unit, as the cost that you incur. Remember, in economics, the word cost has a different meaning than price. Whatever the cost is, you're going to add a markup above and beyond the cost, or above and beyond the cost of goods sold, so that you'll have money to pay for your selling, general, and administrative expenses, and hopefully have some left over for profit. So let's see the impact of possible forecasting error. Let's first calculate the cost of us making a product. Let's pretend it's December, just before the new year. We're setting our budgets, we're establishing costs, which will then be used to set our selling prices. Let's assume we make widgets and it requires $10 of labor, $10 of material to make the widget. Of course, we have an overhead budget, salaries, depreciation, utility expenses, insurance expenses, all kinds of overhead, which needs to be allocated to our products or to our widgets. So if you take in management accounting, you know the traditional way is to spread the overhead over the number of widgets you're planned to produce to get overhead per widget, overhead per unit. So our $1 million of overhead divided by 100,000 planned volume or forecasted volume tells us we should figure an overhead of $10 a unit. So our total cost, again, not price, our total cost is 10 for labor, 10 for material, 10 for overhead, or our total cost is $30. Let's assume we want to mark that cost up by 33%. $30 times 1.33, our selling price would be about $40. Remember, going backwards for a second, we need to mark up on top of the cost in order to cover these costs. But let's say our real volume isn't 100,000, but it's 200,000. If you do this math again, you get overhead cost per unit not of $10, but of $5. The total cost of making the widget is now 10 for labor, 10 for material, 5 for planned overhead, total cost of $25 with a 33% markup. our selling price would be 33. Now we need to invite the marketing or the sales guys here to tell us whether a selling price of 40 or a selling price of 33 would be better for the business. We're not going to talk about elasticity of demand. All I would say, not being a marketing expert, is I'd rather be able to sell my price at $33 and make my 33% markup than $40. Obviously, if the volume was less than the 100,000, we'd have overhead per unit of more than $10. The cost would be more than $30, and our price might be non-competitive. Our price with the markup might be $45, $50, $55. So being wrong on the low side, being wrong on the high side can create problems for the business when they go about setting prices. The text discusses many methods of forecasting consumer demand. We're going to use the well-accepted regression methods, a statistical technique known as regression analysis, to come up with consumer demand going forward based on historical consumer demand. Now, before we get into the nuts and bolts of regression, keep one very important thing in mind. Regression analysis does not assign causality. It can say the sun comes up because the rooster crows. The rooster crowing does not cause the sun to come up. We can, of course, say there's a pretty good correlation between the sun coming up and the rooster crowing. And we could probably make pretty good predictions that if we hear the rooster crow, the sun will be coming up shortly. And that's what regression analysis is all about. Based on past history, what can we predict about the future of the relationship or the correlation between one variable and another? When we do regression analysis, we have to properly identify what is called our dependent variable and our independent variables. We're going to go through an example in a few minutes using different data than you're going to see in one of the assignments, one of the required critical thinking assignments. But the process is the same. The dependent variable I like to consider is the variable you're interested in. The variable whose value, I guess I can't edit that. The variable whose value depends to some degree on one or more other variables. Those other variables we call independent variables. Conversely, the independent variables are variables that impact the dependent variable's value. Now, we're going to learn in this course about simple regression analysis where the dependent variable has only one independent variable of interest. We could easily add 2, 3, 4, 5 more independent variables that probably have some impact from a predictability perspective on the dependent variable. In this course, we're not going to get deep into that. That will be called multiple regression. We're going to stay with simple regression where there's only one independent variable. When I did my doctoral thesis, I believe I started with 17 independent variables. I recently did some research where I started with, I believe it was 28 independent variables. Both of those examples would be multiple regression. Okay, here's some examples. Let me try to crank up my marker. Let's say we're trying to figure out what impacts your lifetime earnings. It would probably be safe to say the years of education you have would be a good predictor of your lifetime earnings. Your caloric intake would be a good predictor of your weight, as would be hours of exercise. So here are two independent variables, calories and hours of exercise, that both affect weight. We could put those both into a multiple regression analysis. Your GPA, that's the dependent variable. What impacts that, or what could be used to predict it? Your hours of study, your hours of video games, if you were my son. Again, you could do two simple regression analyses, or more likely use one multiple regression with two independent variables. This course is all about predicting consumer demand, and some of the things that are typically involved with predicting consumer demand is a population or population growth, or average earnings rising or falling, is GDP growing, or are we heading into a recession, and many, many other independent variables will have an impact on consumer demand. Now, the regression results are sometimes called coming up with an equation of the best fitting line. And I'll show you graphically what I'm talking about there. If you remember from geometry, if you've taken geometry, the formula for any straight line, the y value is equal to the slope of the line times the x value plus what's called the y-intercept. B is the y-intercept, m is the slope of the line. We could surely turn that around and have the dependent variable equals the y-intercept plus the slope of the line times the x value. And this is the format that you're going to see in the regression results in a few minutes. There are at least 5 important results we're going to look at and talk about. And I think my next slide gives you a brief definition of what each of these means. You're actually taking a mini statistics course in this module. I think I'm going to skip over these and go right to the regression because I'll be talking Greek until we start learning about regression analysis. But these are those same 5 or 6 kinds of results that we're going to get from our regression analysis.